We're ready to begin Chapter 4. This is our most important chapter of the entire semester, by far. If you don't learn Chapter 4, you really can't move on from here because every chapter after this, every class after this involves factoring, and that's what Chapter 4 is about. So we start out with polynomials, exponent rules, then we do move on to 8 types of factoring, and every math class, every chapter in this book has factoring. So if there's going to be a chapter you work really hard on, this should be it. And we address exponent rules 3 different times in 3 different chapters, with whole numbers, with negative numbers, and then having exponents that are fractions. So this little box you're going to see many times. Next time you see it will be in Chapter 6, and then again in 8. So 2 of the most missed problems on the test in the past have come from the exponent rules. So I'm going to try to pick ones out as we're doing them to help you narrow it down to which ones you'll see, because as you can see there's like 3 pages of exponents and scientific notation. So properties of exponents, or we call these the exponent rules. So our first property is multiplication. So the base is what the exponent sits on, and then the exponent is what's up in the air. So if the bases are the same, and this is a multiplication problem, we keep the base and we add the exponents. So this would be a to the second times a to the third, for instance, would be a to the fifth. And I think because students have such a hard time with this, because the rules don't follow what you're doing. In multiplication, guess what? We don't multiply. We add the bases. So the rules aren't very intuitive, and I think that's probably why students have a hard time with them, because a lot of students will give me a to the sixth for this while they're working through a problem without thinking. But multiplication, keep the base the same, add the exponents. And division and multiplication are opposite operations, so it makes sense that their rules will be opposites. So if you're dividing and your bases are the same, you keep the base and you subtract the exponent, since it's the opposite of multiplication. So if we had a to the fifth divided by a to the second, we'd keep the base the same, a, and we'd do 5 minus 2 to get 3. So still not intuitive. We're subtracting exponents and division, but at least these operations are opposites, just like multiplication and division are opposites. So multiplication, keep the base, add the exponents. Division, keep the base, subtract the exponents. And order matters. It always has to be the exponent in the numerator minus the exponent in the denominator. And then next is when we really start getting confusing, because now we're going to multiply. And it's not a multiplication problem, it's a power rule. So when you have a base inside with its exponent raised to a power, that is when you actually multiply. So base stays the same, multiply the exponent. So that would be like, let's do this one over here, a to the second raised to the third power. So see how it's similar, but this is multiplication. And in multiplication, we add our exponents. This is not multiplication. This is called raising to a power. So guess what? We multiply our exponents. So see how confusing that could be, knowing when to add, knowing when to multiply. So you really have to pay very close attention. And then if we have a product inside, multiplication, then we just distribute that exponent through, excuse me, by multiplying, because these have imaginary exponents of 1. So you do 1 times m, a to the m, 1 times m, b to the m. So you're multiplying that exponent outside by the exponents inside, but you're distributing it inside. So if we had 2a to the third, let's say, so see how that's a product just like this. I always tell students, if you ever have things without exponents, just put imaginary ones there, because everything has an exponent of 1 if there isn't any number present. So then you do 1 times 3, which is 2 to the third. 1 times 3, which is a to the third. And 2 to the third means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. A lot of students want to write 6 for that. That's when the 3 is down on the ground, 2 times 3. But 2 to the third means 2 times 2 is 4, times 2 is 8. So this would be 8a to the third. And the same rule applies when we're dividing. When we're dividing, inside the parentheses, the power rule still applies. We still distribute it. 1 times n, a to the nth, b, 1 times n, b to the nth. So that would be if we had, for instance, 2/3 to the third. That means, and you can put your little exponent of 1 in, because they don't have exponents, and you do 1 times 3, 2 to the third, 1 times 3, 3 to the third. So you would cube both parts of the quotient. 2 times 2 times 2 is 8, as we just showed above. 3 times 3 is 9, times 3 is 27. Remember, this doesn't mean 3 times 3. It means 3 used as a factor 3 times. So 3 times 3 times 3 is 27. And then, as if we don't have enough rules, now we're going to entertain the negative exponents. Never allowed to leave a negative exponent in an answer. So what we have to do is reciprocate the base, and that makes the negative exponent positive. So b to the negative a, the reciprocal is b is 1 over b, and notice how my a became positive. So that would be, let's do 2 to the negative 3. So we can never leave negative exponents in answers. The only exception to that, by the way, is scientific notation. So what we have to do is reciprocate the base. So the reciprocal of 2 is 1 over 2, and then the exponent becomes positive. So reciprocate the base, 1 over 2, exponent becomes positive. So now this would be 1 over 2 times 2 times 2, which is 1/8. So negative exponents can be made positive by moving them to other sides of the fraction, because right now it's in the numerator. When I bring it down to the denominator, the exponent becomes positive. And anything to the 0th is 1. So we could say 5 to the 0 equals 1. But there's a lot of quirky ones for 0. So I'm going to put some down here. So let's just add some. Let's do negative 5 to the 0th. Let's do 5x to the 0th. Let's do negative 5x to the 0th. And let's do 5x to the 0th. I think I might have all the different scenarios there. So even though that seems like a simple little rule, it can get very complicated. And I did put it on the test, and a lot of students miss it. So that's why I've made up all these different scenarios here. So please excuse my dear Aunt Sally says exponents come before negative signs. So there's no parentheses, so we do exponents. So when we do this problem, we cover this up and we go, oh, anything to the 0th is 1. And then that means change the sign. So this answer is really negative 1. So we evaluate the exponent, because please excuse my dear Aunt Sally says if there aren't parentheses, that's first. 5 to the 0th is 1. This says change the sign. This is read as the opposite of 5 to the 0th. Well, 5 to the 0th we just said is 1, so the opposite would be negative 1. This one I put on the test. A lot of people miss this one. So you do exponents first. This is multiplication, and please excuse my dear Aunt Sally says exponents come before multiplication. And that's what a lot of students don't do correctly. They go, oh, anything to the 0th is 1. Well, this is like this problem. So you have to do the exponent first. So x to the 0th is 1. So this problem is really 5 times 1, which is 5. So yes, x to the 0th is 1. As we said, anything to the 0th is 1. But then this is 5 times 1, because that 0 exponent only goes with the x. And for some reason, students think it goes with both. The only time it goes with both is when there's parentheses. Now the 0 goes with the 5 and with the x. But on this one, you evaluate the exponent 1 and then multiply it by 5. So see if you can do those last two. Shut off your video, get an answer, turn it back on, and then you can check. So this is negative 5 times 1. Again, exponents come before multiplication, so don't multiply those. First you do this. So negative 5 times 1, negative 5. Did everybody get that right? And this, anything to the 0th is 1. So because of the parentheses, look at the difference in the answer here. One came out 5, one came out 1. Why? Because parentheses trump exponents. So this means take the parentheses, raise it all to the 0th power, we get 1. Where here there's no parentheses, so we have to do exponents first, get that 1, and then multiply it by 5. Okay, so we have a couple minutes here, so let's go ahead and do a couple of these. So this means use this base twice. So, and I would write out what it means as well as the answer, because a lot of students don't know the difference between this and this. And we'll do both of them so you can see the difference. So this one means use negative 3 twice. Negative 3 times negative 3, 2 negatives equal a positive 9. But this is like this one. It's read the opposite of 3 squared. So the negative is not used twice like it was here, because this was in parentheses. So this means 2 negatives and 2 3s. This one, the 2 only goes with the 3. So this is what this problem expands as. So see the difference? And I cannot tell you how many students have no idea that those two are different. They treat these two problems the same every time they see them, and they are not the same. So negative 3, positive 9. The opposite of 3 times 3, which is 9. Change your sign.